Hey champions, today we're going to carry on with fractional indices, so following on from the previous video. Okay, so the first couple of questions we've got are expressing in index form. So for this one we want to go from either this type or this type of expression and convert it to index form, this one here. So the first one there, we've got the square root of 29. And remember, if there's no number there, it really means that we've got an invisible 2. So let's draw that in really quickly. Square root of 29 in index form, we write as 29 to the power 1/2. Okay, next one, we've got the cube root of 4t to the power 7. Okay, so for this one, we're finding the cube root of the whole thing. So if we think about that in terms of some of the index laws that we've done previously, what we've really got there is 4t7 to the power 1/3. Because cube root is the same as finding something to the power 1/3. I thought this glittery pen would be a great idea, but I can't read that, so I'm gonna make it a little bit less fun, unfortunately. So it's all that to the power 1/3. So we need to apply that power through the entire bracket. That's going to leave us with 4 to the power 1/3, because really that's a 4 to the power 1, and 1 times 1/3 is just 1/3. And we've got t to the power 7 multiplied by 1/3. That will give us t to the power 7/3. Lovely. Okay, we'll apply the same technique to the next one. So 8 multiplied by m to the power 4 raised to the power 1/8, because it's the 8th root for that one. So here, if we change that to index form, we've got 8 to the power 1/8, and then m to the power 4 multiplied by 1/8, which gives us 1/2. And for the next one, this is another one where the 6 is not invited to the party. So it's 6 multiplied by the cube root of n to the power 7. So for this one, we've got 6 multiplied by n to the power 7/3. And that's all we need to do for that one. So that 6 doesn't get involved with our converting it into index form, because it was multiplying the surd to that root to begin with. Okay, next one we're going to express in surd form. So we'll start off here with 2 to the power 1/5. That means we're finding the 5th root of 2. Great. Okay, the next one, 7 to the power 2/3. We'll rewrite that as 7 squared. And we're finding the cube root of that. We can make that a little bit easier to digest because 7 squared is pretty straightforward. So I'm going to leave that as the cube root of 7 times 7, which is 49. And I'll do something similar for this next one. I've got the 7th root of 3 to the power 4. But 3 to the power 4 I can evaluate pretty easily. So I'm going to write this one instead as the 7th root of 81. Lovely. Well, we're moving through at a bit of a pace today, which is good. Okay, the next two are going to be evaluating without a calculator, and then we'll move on to some simplifier ones to finish up. Okay, so when we evaluate, when we see that word evaluate, we need to spit out an actual number as our answer. That could be a fraction as well as an integer, but it's looking for some sort of value for our answer. So for the next one, 64 to the power 1/3. It's the same as finding the cube root of 64, which would be 4 for this one, because 4 times 4 times 4 would give me 64. The next one, I've got to do a little bit of rearranging. So I've got 32 to the power -1/5. That means I'm going to rewrite that as 1/32 to the power 1/5, which means I'm finding the 5th root of 32, which is just 2, because 2 times 2 times 2 times 2 times 2 will give us 32. Now for the next one, this is a good example of where you need to remember from the last time we got together, if we're going to evaluate or convert this to surd form, we could either write this as 8 squared and then find the cube root of our answer, or we can find the cube root of 8 and then square our answer. There's not a lot in it for this one, especially when you compare it to the next question that we do. But for this one, if we find the cube root of 8 first, and then square the answer to it. The only reason for that is the cube root of 8 is 2, and 2 squared is 4. Similarly, if I'd done 8 squared first, it would have given me 64, and then I would have gone on to do the cube root of that, which would still be 4. It's just slightly harder. So you want to make it as easy for yourself as possible. This especially applies to the next question, where we have the option of doing 16 to the power 5 first, mentally, which I don't really fancy doing, and then finding the 4th root of that. Or we could find the 4th root of 16 first, and then raise that to the power 5. That seems much, much easier to me. So that's what I'm going to do. So I'll just rewrite that here for nice working out related reasons. So 4th root of 16 is 2, and then 2 to the power 5 is 32. Happy days. So in that example, that second way was the easiest way of getting things under control. You just got to pick the one that suits the situation you are in best. Okay, these ones are a little bit harder, but they're not too bad. These are examples of simplify questions. So the first one I'm going to do is here on the left-hand side. I'm going to do something similar to what I did for one of the other examples above. I'm going to say that the square root of 25s to the power 4 is the same as saying 25s4 to the power 1/2. Now I can use index laws to chop that all the way through the bracket. So the square root of 25 is 5, and then s to the power 4 multiplied by 1/2 is s to the power 2. Awesome. So this is a good example of where the skills that you learn before you get to year 10 with index laws actually start to add up, and you draw on your previous knowledge and you apply it as you enter year 10 and beyond. And all these index laws things are really important for methods and further study in maths, so it's worthwhile getting a good handle on it. Okay, and for the penultimate question, we've got 125t to the power 12, and we're finding the cube root of the whole thing. So I'm going to raise that to the power 1/3. Cube root of 125 is 5, and then t to the power 12 multiplied by 1/3 is t to the power 4. So using one of my index laws for that one. And then next one, we've got 8x cubed over 27, and we're finding the cube root of the whole thing. So I'll do something similar for this one. 8x cubed over 27, and the whole thing is raised to the power 1/3. So similar situation again. I've got to raise each of the terms, well, not each of the terms, sorry, each of the coefficients and the variables in that expression to the power 1/3. So the cube root of 8 is 2, cube root of x to the power 3 is just x, and the cube root of 27 is 3. So a simplified answer for that one is 2x/3. Then you give yourself a little pat on the back and say, well done, good job.